90% of all chemical compounds contain carbon. We will consider the geometry of carbon in molecules throughout the semester. Since carbon never has any lone pairs of electrons in a Lewis dot structure, the number of atoms directly bonded to carbon determines the molecular shape. Table 3.7 summarizes the three shapes that are possible for carbon. If there are 4 atoms bonded directly to carbon, the shape is tetrahedral, and the bond angles are 109.5 degrees. If there are 3 atoms bonded directly to carbon, the molecular shape is trigonal planar, and the bond angles are 120 degrees. If there are 2 atoms bonded directly to carbon, the molecular shape is linear, and the bond angle is 180 degrees. The tetrahedral shape extends into 3 dimensions, and chemists use the wedge and dash or hatch notation to better illustrate this 3-dimensionality in the 2 dimensions of a page or computer screen. Of the 4 atoms that are bonded to carbon in a tetrahedral arrangement, 2 are in the same plane. The atoms that are in the same plane have bonds which are drawn with solid lines. One of the atoms bonded to carbon will be in front of this plane, and that bond is designated with a wedge. The last atom bonded to carbon is located behind this plane, and that bond is designated with a dash or hatch marks. You will be expected to determine the shape of atoms in a molecule, and you can still use Table 3.6 to determine geometry. The molecule in this slide has 2 carbon atoms, and each is bonded to 4 other atoms. Therefore, each carbon has a tetrahedral geometry, and the bond angles are 109.5 degrees. There is also an oxygen in this molecule, which is singly bonded to 2 other atoms and has 2 lone pairs of electrons, so its geometry is bent with a bond angle of less than 109.5 degrees. Don't be fooled by the Lewis dot structures which show bond angles at 90 degrees. The Lewis dot structure is a model, and we have to look at how many bonds and lone pairs there are to figure out the actual geometry and bond angles.